Hello. So today I'm gonna to demonstrate my second mini project is about Simulink. So first I will describe the basic idea of this project. So I try to simulate the inverted pendulum system or CartPole system. The goal of this system is to control the force and make the the pole to be upright position. And here is the equation. To create model in Simulink, we need this equation. Let's start with the plant model first. So one approach to create a model we can do like this by using the function block. We can add the equation inside, and by getting the the indication we can use integrator box to create the plant model like this. Another way to create is use a Simscape. So Simscape have have the hardware model, and we can simulate that hardware, and we can adjust the the dimension of the hardware, like the length or kind of the mass. Yeah, so we can create the real hardware in simulated environment. In this uh project, I try to use the created Simscape model. So we can the good thing when using Simscape is we can uh, have a good visualization. So the conventional way to control this system is to use a PID controller here. Uh, sorry, this one. So uh, we have PD controller to control the position, and second order state space controller to control the angle. Yes, like this. So in Simulink, we can use tuning goal and systune to tuning parameter to tuning gain of the controller. Here is the pre-tune. So I will run it to see how it works. As you can see, the conventional model can control the the pole to be upright position. The pole is start from upright, and the controller try to make it stay upright like this. So in this approach, I try to replace the conventional controller with reinforcement learning. So the basic idea of reinforcement learning is we have agent and environment. Environment will be the, the plant model, which is CartPole, and the agent will be the one that we will create. The agent will take action to the environment. Here will be the force. The agent try to give the force to be input for environment. The environment will give observation, which is the position of the car, the angle, the velocity, the angle velocity, and also the reward. The reward function will tell the agent that the action is good or bad, and agent will improve. So key point here is the reward, how to decide the good reward to make the agent can learn. So the reward in this system is this equation. As you can see, the highest gain is the angle. The goal of this project is to control the angle to be upright position. In this position will be zero angle. So we try to minimize this equation to get maximum reward. So we should have minus here. The base angle is 0, and next is about the position. So we don't want the card move too much from the center position. So here is the one of uh, constraint, also important. And the last one is about the previous action is also important, but not that one. Here is kind of a penalty that we don't want the card to go out of bound too much. So let's start with the Simulink model. So here is the model. We need to use uh, RL agent block to create the reinforcement learning. As you can see, this block is uh, already this block replaced the conventional controller. To train the model in Simulink, we to train the uh, reinforcement model and using Simulink, we need to train in MATLAB. First thing we need to do is we need to import the Simulink environment into MATLAB environment. So by using the Simulink environment function, we can import the model into MATLAB. Here import to environment variable, and next we will create the agent to train for training the model. So by creating the agent, we need two components. First is critic. Critic is the neural network with two input, which is state or observation and action or force. And and here I use a GPU flag to make the training faster. And the second component of the agent is actor. In this system I use a DDPG agent. So DDPG agent will search for an optimal policy that maximize the expected cumulative long-term reward. So the actor will have one input, which is uh, observation, and one output, which is action. And so the agent will be combined with actor and critic. Yes, and we will have 2000 episode for training, and the training will stop when the reward more than minus 400 over 5 consecutive times. So here I use this flag to use parallel. This make training process faster. And here is the training page. As you can see, the training stop when the reward is more than minus 400. So I already train and save. I can show you now. Here it is. Okay. So first, the pole is go down, and the agent try to control and let it upright. We have some disturbance, and agent can fight with it and make the pole still upright. Yes. So this is some conclusion, some comparison. So as you can see, the PID need to start with angles 0, which is upright. They need some time to make the stable, but the reinforcement no need. And next is when we start with down position, PID cannot support, but reinforcement can support and also deal with disturbance very well. So for the conclusion, I think the reinforcement is better than PID. Thank you very much.